Okay, then we are going to understand this method in a deeper way by some more simulation studies. Okay. Uh, First of all, so currently we have 10 regressors and observations are 100, and then true values are the first two coefficients are 2 and the others are zeros. And then here I just put 1. Okay, let me change it to 4. Okay, and sigma square is 1. Okay, and B0 is, I say, 0.0001. Okay, then let me run this code. Okay. Yeah, it looks good. By the way, I don't like this figure very much. Here, the x-axis is what? The just variables or the regressors, and then this and these values are the posterior probabilities of inclusion, okay, or the posterior probability of importance of each regressor, right? So then I think, okay, let me show you again. Okay, here, okay, then here F9, right? Okay, so then this is line. Then I guess the bullet would be, or bullets or bubbles would be better looking, I guess. Okay, let's try this. And then this sort of the figure is called scatter or scatter plot or bubble plot. Okay, let me show you how to do this. Okay. Okay, then I don't need this one figure, and then say x is 1 colon k, and this is sorry, this is the x-axis. Okay, then okay, let me put some limit, y lim bracket, say 0.01 1.1. This defines literally limits of the y-axis. Okay, so then this probability ranges what? This probability ranges from 0 to 1. So right. So that's why I put minus 0.1 and 1.1. Okay, and then x limit. Okay, variable name start 1. So then I would say 0 k plus 1. Also k plus 1 bracket. And then I have to put this bubble size. So usually 40. Okay, so then scatter. Okay, x, the first input has to be x, and the second input must be y. In this case, y is here, right? Also, then let's just define y here. Okay, the posterior, again, this is the posterior probability of inclusion, right? Y. Or you can say that there's a posterior probability that each regressor should be included, right? And the third input argument is the bubble size. Okay, x-axis and y values and bubble size. That's it. Okay, and then x label. X label is just variable. And y label. is the probability of inclusion or probability of importance. And then let's try to run this. Yeah, looks better, right? But the I wanna add some. I wanna this line to be thicker, and then also I wanna fill these bubbles. Okay, let me show you how to do this. Okay, so here. Okay. Marker H color. Okay, I want it to be, say, blue, and then I think I have to add the marker face color and line width. Then this line could be too long to put in one line. So then in this case, I can do here dot dot dot. Then it means that the one line continues. Okay. So then here marker face color. I want green. Let me try green. And I want the edge to be thicker, edge line to be thicker than line with this. Okay. Usually 2. Okay. Then it's done. Okay. Right. So you can find these options in Google or in this help option. Okay. Then let me run this editor, and then yeah, much better. Yeah, much better, right? Much better. Okay. Okay. So then, oh, something strange here. X lim is 0 to k plus 1, but 0 is 0 and k plus 1 is 11, but I can't see 0 and 11. I don't know why. That's weird. And also y lim is -1 to 1.1, but the limit looks like just 0 to 1. That's weird. Okay, let me try -1. Okay. F9. Something weird. Maybe X lim and Y lim do not work in this scatter plot. Maybe. Okay. Okay, but this is not a big deal. Okay. Okay. So then, okay. Currently, we have 10 regressors, and suppose we have, say, 30 regressors. Let's see what happens. Okay. Right. Okay. Still looks like it's working very well, right? So it's working very well, right? But this is not what I want. And let me try 40. And maybe this is too high. Okay. It's running. Yes. Okay, this is what I want here. Again, this is the case of 40 regressors. And then here, these probabilities relatively high, right? And of course, this one, the third one is much higher than zero point 0.8, right? The true value is 0, right? True value for the third regressor coefficient is 0. But despite that, the probability of inclusion or probability of importance is higher than or larger than 0.8, right? This is totally inaccurate, right? And so are these coefficients, right? Okay. But what if I try 10 again? Yeah, it's much better, right? Although this is still 0.8, 0.4, but this much smaller than 0.8, right? So then it implies what? It implies what? So then the number of important regressors is the same as before. Still we have two important regressors, right? But if we have too many unimportant regressors, if we have too many unimportant regressors, then we might have some inaccurate result in which the unimportant regressors can be mistaken as important regressors, right? So then it means what? Still, it means what? The more regressors do not necessarily imply the better approach, right? So this method will categorize the important and unimportant regressors, but its performance depends on how many unimportant regressors are considered. If we consider too many unimportant regressors, then this method may not be reliable enough, right? So although we use this very sophisticated method, still we need to choose some proper the set of the regressors. Okay, so simply you can't simply include any regressors, right? Okay, you need to sort some variables so that the estimation can be more efficient, or the results are more accurate. Okay. Okay. Right, and then let me try with this B00. Okay, let me run this again. Okay, and then if I change this B0 to say 0.1, let's see what happens. Yes, a bit better, right? Much better, right? Here, right? Previously it was 0.4, but now it's a bit less than 0.2, right? So then result is quite sensitive to the choice of B0. Okay, let me try with 1. This is so big, but let's see what happens. See here, if B0 is too large, here this probability is less than 0.7. The second one is less than 0.6, right? True value has to be 1, right? True values are 1. So then it means what? If B0 is too large, so then the posterior probability of importance or inclusion could be underestimated. The question is why? And then also please look at here. This is almost 0.2. The true values are 0, right? True values are 0, but this is higher, and these values are lower than the true values. The question is why. Here, this is 1. So this is prior variance of what? Unimportant regressors. Sorry, unimportant regressors. But this variance is quite large, right? This variance is quite large. So because of this, these important regressors can be also generated from these large prior variances, right? So that's why these probabilities are quite high, right? These probabilities are quite low. Again, so here, suppose this is 0.6, okay, roughly this 0.6. So then this is posterior probability of important regressors, right? So it means what? 0.4 is what? 0.4 is what? Posterior probability of unimportant regressor, right? It means what? This with 40% of 40% probabilities. These the first here. This is second regressors coefficient. Second regression coefficient can be generated from this prior distribution rather than this one, right? So then these outcomes are also quite sensitive to the choice of B0. B1 is usually very large, okay, but these positive probabilities are very sensitive to the choice of B0, right? Okay, and then right, okay, let me go back here. So then this shouldn't be too large or shouldn't be too small, and we have seen this before, if I remember correctly. Okay. Yeah, this is too small. Okay, this is too small. It means what? This is too small. This is too small for unimportant regression coefficients to be generated from this prior distribution, right? This is too small. Okay, so then when you forecast any variables, you are going to try quite different values of B0, so that you can get more accurate forecast, or the better or more sensible results, right? This sort of the process is also called tuning. Okay, you have heard of tuning in the video for the machine learning, right? Okay, let me go back to the just normal or just proper value 0.001 or 0.01. Yeah, that's still good. This is good enough. Okay.